Hi everyone, welcome back. What we're going to start doing today is we're going to start to look at surface area of a couple new shapes. So we've done a few already. We're going to look at how to find the surface area of pyramids and cones today. And so we're going to start with what it makes to be a pyramid, and then we're going to see if we can figure out how to find the surface area after that. So to be a pyramid, here's what has to happen. We have to have a polygon for the base, any polygon at all, and then all of the lateral faces. Lateral faces is just the name for the faces that are not the base. So all the lateral faces are triangles. And those triangles all meet at a common vertex. Now when we say pyramid, what comes to most people's minds is like the pyramids in Egypt, which is okay because that is a pyramid. But the base does not have to be a square on a pyramid. The base can be a lot of different shapes and it's still a pyramid. I have a couple that I wanted to show you here that are pyramids. So we've got what you guys are probably thinking when I say pyramid, something like this. Square base comes up to a point at the top, that's a pyramid. Right? But this is still a pyramid, rectangular base, still a pyramid. This is a pyramid as well, triangular base, still a pyramid. So we call this thing a triangular pyramid, or we can have a rectangular pyramid, or a square pyramid. We could also have a hexagonal pyramid, a hexagon for the base. So we could make a lot of different pyramids. Now, one big thing, if we're going to find the surface area of one of these, what we're going to be finding surface area for the most part is regular pyramids, ones that have a regular polygon for the base. So that rectangle, for example, would not be a regular pyramid because the base is not a regular polygon. But to be a regular pyramid, this would work. This is not the only one, but there's a big variable here that I wanted to explain because we've done most of this. So surface area is capital B. Remember, capital B stands for area of the base. And then plus 1/2 capital P. Capital P stands for perimeter, distance around the outside of the base, times L. L stands for the slant height. And so in a pyramid, we've got our regular height. Our regular height would be like this gold stick in the middle. The slant height would be this red string right here. It's not the edge is the green string. The red string right here, that's the slant height. Basically, the slant height is the height of the triangle that's the lateral face. So slant height is that part right there. And we're going to have to think about how to find that in just a minute here. But I really want to make sure we got it down what the slant height represents. This is height, H. That's not what we have in this equation. This is slant height, L. That's what we have in this equation. So that's what we're going to have to use in order to use that equation. Now, as before with surface area, if you'd rather ignore this equation exists and then just find the area of every single face, in this case there's 5 faces, if you wanted to find the area of all 5 of these faces and add the answers together, that would work just fine as well. You don't have to use this formula. So let's see if we could find the surface area of this one. So we've got a square pyramid here. And if you notice on this one, I didn't give you the slant height. I gave you the regular height. So we're going to have to do a little work here to figure out the slant height. And so the regular height is 10. The base, this is a square base. We've got 8 and 8. So the slant height would go right here would work. So I'm going to go from there down to there. There's the slant height. Now, something that I want us to notice about what shape is created if I look at a couple of things put together here. I'm going to make a segment here too. And then I'm going to pull this thing back up that I had just a second ago. Now what I want us to notice, kind of ignore this edge. So I'm going to take this edge off so it's not in the way. I'll even take this one off. If we look at what shape, when we have the regular height, the slant height, and then half the base, do you notice the shape we always create here? Since the height is perpendicular to the base, that's a 90-degree angle. And so we've got a leg, and a hypotenuse. In other words, we've got a right triangle. And the slant height is the hypotenuse of that right triangle. So we've got the same thing going on here. We've got 10 for the one leg. This leg right here, do you notice the entire length is 8? So like looking at our one we have here, we're saying that's 8, which means this part right here would be 4, because that's just half the distance across. And so what we've got here going on now then, we've got 4 right there, we've got 10 right there. We want to know the hypotenuse of that right triangle, so it really comes down to an a squared plus b squared equals c squared problem, Pythagorean theorem. And so we're going to do something like 4 squared plus 10 squared equals, you could call it c if you want, but since the variable for slant height is L, I'm just going to call it L squared. So 4 squared we get 16, 10 squared is 100. And so we've got 16 plus another 100 equals L squared. And so we've got 116 equals L squared, which means if I want to get L by itself, I've got to undo the square, take the square root. And so it's the square root of 116 if we want an exact answer. Now, since we're going to have to plug it into here in just a second, I'm going to go ahead and get this as a decimal. This is approximately, if I go to like the nearest 2 decimal places, 10.77. So that's our slant height here. Now everything else I think we can find here. We don't have to do like a lot of background math to figure out. So the area of the base is a square. Remember, the way we find the area of a square is just length times width, or the side length squared, you could say. And so it's going to be 8 times 8. So the area of the base on this one is just 64. The perimeter of the base is just distance around the outside of the base. And so the base is 8 plus 8 plus 8 plus 8 for the perimeter, or 8 times 4. So that's 32. And so let's put it all in here. So to find the whole surface area, we've got area of the base, 64, plus 1/2 times the perimeter of the base, 32, times the slant height, which we just found out a minute ago, is 10.77. Right, so there's basically all the math we want to do to find the surface area. So area of the base plus 1/2 perimeter of the base times the slant height. And if we do all this, multiply all this out and then add it together, we're going to get the surface area of this one is about 236.32 square inches. Now remember, we're talking area, so that's why I said square inches at the end of this. So that's how we find the surface area of a pyramid. So the other shape that I wanted to talk about just a little bit here is how we find the surface area of a cone. And so I have a cone drawn here, and I just wanted to talk about what makes something a cone first, and like talk about the pieces of a cone. So a cone has a circle base. And then there's still a common vertex, but we can't say the faces meet at a common vertex because this whole thing is not really a face. It's like a constantly curving thing around. But it does come up and meet at a single point and stop there. Right? For the parts of a cone, we've got a height, which goes from the center of the circle up to that common vertex. We've got a radius, just half the distance across the circle, just like radius has always been. And then we've got a slant height right here. So slant height is still L. We're still using the same variable for that. And looking at it from a side view, you notice we have the same thing going on with this being a right triangle. I'm even going to put one more thing in here. I'm just going to put a little right angle box in there. So we could say on this that h squared plus r squared equals L squared. Just using a squared plus b squared equals c squared, so we could find the slant height if we knew the radius and the regular height. Now the way we find the surface area of this is pi r squared plus pi rl. Now if we were in school right now, I'd go through the whole derivation of why that formula is what it is. But basically this part is the circle for the base. Area of a circle is pi times radius squared. Pi rl is how we get the area of this curved thing that's going around this lateral area. And so that's our formula for surface area. So let's see if we can put this to use on a problem right here. So we want to find the surface area of this cone. And I shook things up a little bit and I turned this cone on its side. Now remember, height, really in all these 3D shapes, height doesn't mean up and down. Height is always defined to be a certain length that connects certain things. In this case, it goes from the center of the circle to the common vertex. So the center of the circle to the common vertex, this, even though it's horizontal, is the height. So the height is the 18 feet here. And then the radius is the 8 feet. Now the part that we don't have here that we need, do you notice h is nowhere in this equation? But L is, and L is unknown in this one at this point. So we're going to have to figure that out here. So L is this slant height right here. So we're going to have to figure out what is that length. And again, we've got a right triangle going on, so it really comes down to doing a squared plus b squared equals c squared to get this. So we're going to do something like this. 8 and 18 are our two legs, or our a and b in there. So we're going to do 8 squared plus 18 squared equals L squared. 8 squared, that's 64. 18 squared, that's 324. So I got 64 plus 324 equals L squared. Put those together, and we've got 388 equals L squared. Now I'm going to go ahead and get that as a decimal because we're going to need to put it in there in just a second. You could say the square root of 388, and that would be an exact answer, or you could break down that square root, but I'm going to leave it just like that. And then L is approximately then, if I get this as a decimal, it's about 19.7. Comes out to like 19.69 something, and so it's about 19.7 for the slant height. And so now to find the surface area. Well, I think we've got everything we need in here. We've got R is 8. We've got L is 19.7. So we're going to do pi times 8 squared plus pi times 8 times 19.7. And that'll give us our surface area. And I'm going to get this as a decimal. On some questions, you might be asked to leave things in terms of pi. It's a little hard on this one because we've got this answer that's like a rounded answer. So on this one, we're going to get the answer as a decimal. So we'll say the surface area on this, just like plugging all this in basically. And you could type this all in a calculator just how it is, or you could do each part separately. Pi times 8 squared, get that answer. Pi times 8 times 19.7, get that answer, then add them. But whichever way you do it, and you can check this on your calculator, make sure you're doing it in a way that you get something about like this. I got about 696.18. The other thing that could cause just a little bit of rounding difference, I use the pi button. If you use 3.14 for pi instead, you're going to get a slightly different answer. It should be real close to the same answer. So if you get like, like 3,000 or something, that's not rounding difference. But if you get like 697, that might be rounding difference. All right, so there's how we find the surface area of a cone. So pi r squared plus pi r L. So those are our two shapes for today. How to find pyramid, how to find cone, what those are, and how to find the surface area of them. I thought I would give you guys a little glimpse of what quarantine life has become for me, and I know that you can relate maybe. But as you guys can probably see by this, my kids are huge Harry Potter fans and also big Lego fans. And so this is what we did for a couple days over spring break. They weren't very good at keeping all their Legos together originally though, so when we started spring break, all of these were actually just in a pile in there. And so we spent probably, I don't even know how much time, a ridiculous amount of time, going through somewhere around 4,000 pieces of Legos and getting all this put back how it was supposed to be for their Harry Potter stuff. And so I know you guys probably have your own stories of doing things like this that you have put off for a long time, or just anything to keep you from being bored. So I just thought this was an interesting one, so I thought I'd show you guys that.